starting. Sorry for the delay, but we are ready. Dominic, thank you. Kareem, Wyatt, can you go back to your slides? Thank you. All right, so we're going to talk today about word problems that involve work, and these are basically just a variation on rate times time equals distance, where instead of distance, now we have the amount of work done. So here's an example. In order to pay for their magic habit, Sal and Liam get a job cutting lawns in the summer. Sal can cut a lawn in 2 hours, and Liam can cut a lawn in 3 hours. How long will it take them to cut one lawn if they work together? Let's put this into a table, just like the tables that you used for rate times time equals distance. So we're going to have the rate, the time, and the work. And we're going to have Sal and Liam. So let's start by looking at the unknown. What is not known here?
Time.
The time. Yeah, how long it's going to take them working together. So we're going to call that X. Now we do know the time that Sal can cut one lawn in, right? But that's not what we're looking for. And so it's important to realize that this table is going to be about the time it's going to take them together to cut one lawn. That's what we're making a table for. So that time is unknown. Now what's their rate?
3.
How fast can they cut a lawn, in other
So for
words?
Sal, it's 2.
Okay, so Sal's rate is 2 hours, but that's a time, that's not a rate.
It's one.
So what's the rate?
One lawn for 2 hours, so 1.5.
One lawn over 2 hours. So Sal can cut one lawn in 2 hours. He can cut one lawn per 2 hours. And so the time is going to go in the denominator, and the amount of things he's doing is going to go in the numerator. So Sal was 1 over 2. What would be Liam's? 1 over 3.
So then 1/2 x and 1/3.
Now, to get the work column here, we're just going to multiply the rate times the time. And generally the way that you'll write these is with the x up in the numerator. So I could write this like this, 1/2 x. But I think it's going to be a little easier to just write it as x over 2. So Sal was x over 2. What's Liam's work going to be? X over 3. And this isn't really important for solving the problem, but this is telling us how much of the work Sal is doing and how much of the work Liam is doing. Okay? So that's our basic setup, and now we're going to create an equation. And these equations are nice because very often they're just going to be equal to 1. So what we're going to say is the amount of work that Sal does plus the amount of work that Liam does has to equal 1. This 1 represents the one lawn that they're cutting together. Right, so if I had said, how long will it take them to cut 2 lawns, this would be 2. If I had said, how long will it take them to cut 9,789 lawns, this would be 9,789.
Oh no, how many lawns?
Does this look familiar at all? What type of a problem is this now that we've got it all set up? Sal? Was that a hand?
It's a ratio problem.
It's a ratio. In other words, a rational expression, right? Which is where the word ratio comes from. Rational. So the way that we're going to solve this is to multiply through by 6, which is the lowest common denominator, the LCD. So we want to get rid of this 2, and we also want to get rid of this 3, so we have no fractions. So I'm going to multiply everything by 6. 6 times x over 2 is 3x. I'll move in a second, Liam. 6 times x over 3 is 2x. And 6 times 1 is 6. Now we're just going to combine and solve for x. So 3x plus 2x,
1 and 1, 6.
5x equals 6.
1/5.
Oh,
X
equals
equals 6 fifths. Yeah, and I would probably write this x equals 1.2. Then I'm going to look back at my original problem. What was it asking me? How long will it take them to cut one lawn if they work together?
1 hour and 2 minutes.
And so the answer I would say, it will take them 1.2 hours to cut a lawn. And I would leave it as 1.2 hours. How many minutes is 0.2 hours?
20.
No.
12.
It's definitely
It's
not
12.
20, but right. So we could figure out 1 hour and 12 minutes, but it's just a lot easier to write it as 1.2.
How big is that one?
20 minutes is a third of an hour.
Yeah.
So
How
that'd be
big is the
1.2.
lawn, Nate?
I don't know,
I think
but
it'd be very big.
but maybe they're using those old-fashioned lawnmowers.
Oh,
You know, the push ones.
Wait, isn't that what
Okay.
everyone uses still?
no.
be giant.
No.
The rider?
No,
Yeah,
not.
there's
I mean the ones that
rides.
don't have
Like the little metal ones, like
the ones that don't have gasoline.
Oh.
Like not like the ones you have to
use those.
squish
All
like.
right,
No, not those ones. It's the ones that
let's
you
take a look at
squish
another
and
problem.
Spin with the wheels.
Oh,
Ready?
they're really aren't.
Let me see. Where's my next problem? Okay. So there's kind of another variation on these, which are pipes. So pipes filling up tubs or pools or something like that is another example of a work problem, even though it's not quite going to seem like it. So I'm just going to use this one from the book without adding any fun names and anything. It says one pipe can fill a tank in 5 hours.
wasn't this on the homework a while ago?
Yeah, even though I guessed I got it right, there's only one answer.
Yeah, that's why we're doing these, is because a problem like this was on that
Standardized test prep.
standardized
I
test
actually
practice.
got that answer just because it was the only one that looked correct.
A smaller pipe can fill the tank
Oh, we did this kind of thing.
in
I know.
3 hours. This problem is kind of poorly written. I would think the smaller pipe would take longer to fill the tank, but that's what it says. Okay, how long will it
Maybe
take?
the water is going faster in the smaller pipe.
Right. How long will it take both pipes
What if this was like a tiny fish tank?
to fill the tank
It's like drop.
at the same time? Okay, so again, this time instead of people we've got pipes, and instead of lawns we've got this tank that we're trying to fill up. But again, we have time, and then we have a job that's being done. We have some work that's being done. This time the work that's being done is filling up a tank. So I'm going to make the same chart. I'm not going to make it without marker. So we'll just say pipe 1 and pipe 2. Rate, time, work. What is the rate of pipe 1? Gabe, what's the rate of pipe 1 going to be? Very close. That's the time, right? Yeah. So 1 tank over 5 hours. Thank you. And then number 2, Karen, can you tell me the rate for pipe number 2?
1/3.
1/3. Okay. Great. Time. What's time?
No No idea.
X, right, no idea, we don't know, so it's X.
They don't know yet.
Don't know yet. We will know soon. Okay, and then how about if we multiply rate times time to get the amount of work?
X over 5.
Okay, so Alex, this one would be x over 5
And X over 3, right?
and x over 3. Okay, now we're going to set up our same equation. The amount of work done by both of, that's a messy x, by both of these pipes together, pipe 1 plus pipe 2, has to equal 1 tank, because they're filling up 1 tank. So equals 1. X over 5 plus x over 3.
So if it was like, how long would it take to fill multiple pipes?
Right, exactly. Now, for some reason you don't see a lot of problems like that. I don't know why that is exactly, but you almost always have a 1 over here. Almost always.
Wait, how would you do this like backwards? What if we gave you like how long like one pipe could fill up the tank and then it told you how many?
Yeah, we'll get to some problems like that in a second. Okay, again, we're going to multiply through by our LCD. What is the lowest common denominator of 1/5 and 1/3? 15.
15.
So then I have 3x plus 5x equals 15. In other words, 8x equals 15. So x equals 15 eighths.
1 and 7.
Beautiful.
Wait, should we simplify it?
Yeah, so according to the book, 15 eighths is 1.875 hours. Let's go back up to our problem.
For the homework, can we leave it as a fraction?
Yeah, 15 eighths is fine. Or 1 7/8, or 1.875.
Can you round it so it's 1.9?
Nope. Don't round it. Okay. One pipe can fill a tank in 5 hours. A smaller pipe can fill a tank in 3 hours. How long will it take both pipes to fill the tank? It
1.875.
will take 1.875 hours for both pipes.
So, Alex, why would you not want to round that?
Because you gotta be specific. It's exact.
Yeah.
What?
You have to be like specific.
Right, I mean, it ends, right? I mean, it's exactly 1.875. Why round it? Because it's just 3 digits. It's fine. When you round, it's when they go on forever, right? Because you don't want to spend the rest of your life writing the answer, right? Right?
Yes, yeah.
Right. All right.
In 25 years, she comes back.
I have the answer.
Okay, so now let's look at some kind of variations. Are there any questions about that setup there? So basically we're putting the rate in the first box. The time was x, because that's what we were looking for, and then we're just solving our fraction. Any questions about that type?
Not at all.
Nope? Okay. Let's move on to one that's a little bit different. Guys ready? And will the other colors show up if I use a different color?
Not very well.
Okay. We'll stick with black.
Yeah.
All right.
Draw like a white marker.
Here we go. Elizabeth can clean
10,000 horses.
her locker
Her locker. I need to clean that. Wait.
in 8 hours.
Oh, wow.
That's a beautiful equation.
Her assistant
Clean it in 2 hours.
Gary
Your locker cleaning assistant can clean it in 24
Can
hours.
clean the same locker in 12 hours.
What are you hiding in your locker?
Taking your time there, huh?
Elizabeth,
Okay.
what do you keep in your locker?
So this is where this problem's going to be different,
Covered wall to wall.
right? If Gary shows up 2 hours late,
Oh no.
how long?
Wouldn't it just be x plus 2?
Let's look at it in a second. How long will it take before the locker is clean?
I bet you're gonna like spend the rest of your life cleaning lockers.
Gary, why are you so late to clean the locker?
Okay,
That just adding.
so we're gonna do the same. We're gonna do the same setup, the exact same setup of our table. It's just the equation that's gonna be a little bit different. So we're gonna have Elizabeth. We're gonna have Gary. We're gonna have rate times time equals distance. Okay, can I get a volunteer to?
Equals distance.
I mean work. Thank you. Can I get a volunteer who thinks they can tell me what the two rates are going to be here? It's the exact same as the last problem. Clayton.
1 over 8 and 1 over 12?
Good. So just like the last problem, it takes in 8 hours she can clean one locker. In other words, her rate is cleaning one locker per 8 hours. 1 per 8 hours. And Gary can clean one locker in 12 hours.
Nate.
Now, it's kind of useful, I think, when you talk about the rate, to actually look at this equation in a slightly different way. So if we looked at this equation as rate equals something, what would that something be? Not time, yeah,
So I was
not
looking at the
distance,
D.
but work divided by time. So this is kind of where we're getting this box. We're taking the work that they can do in a certain amount of time. So one locker in 8 hours. One locker in 12 hours. That's what's giving us this box here. Okay, how about the time? What's our time going to be in this equation? So we're just going to call it x for now. There are other ways you could do this, but let's just say it's x. The time is unknown. It's just the total amount of time that they're working. And then the amount of work done, we'll just do the same thing, x over 8, x over 12.
Plus 2.
And now what we're going to do is, when we set up our equation, we're going to take into consideration this part. Gary shows up 2 hours late. Okay. So Gary shows up 2 hours late. The reason that we're gonna save this for later is so that when we get x, we're done. If we set it up a different way, we might get x and not quite be done. And I think that can be really confusing. When you get x and there's something else left to do, like you have to go plug that back in, it's easy to forget that last step. And I don't want you guys to forget the last step. So instead, let's now think about, when Gary shows up 2 hours late, how much work has Elizabeth done?
2.5.
She's done 2 hours times 1/8,
So 2/8.
which is her rate. So she's already done
1/4.
2/8. She's already done 2/8 of the work by the time Gary shows up. That's already done. Then we're gonna add. We're gonna add to that.
My goodness. Oh my god, do people in our school know how to clean properly?
Nope. Or show up on time.
So then we're gonna add to that these other rates. X over 8 plus x over 12.
Pretty slanted.
That is pretty slanted. We should have a lined board for
Yes.
teachers like that. Okay. And that's going to all equal 1. Yeah, almost always 1 because we're cleaning one locker.
Would you combine the, so would it be x plus 2 over 8 plus x plus 12?
What I would do is just clear the fractions. But you could do that. Yeah, Gary.
So I have a question for everybody. Why didn't he put an X after the 2 8s?
Because that's a separate part. And the
Because
2 hours.
The time wasn't unknown.
Right, because the time here is not unknown. Good way of putting it right now. The time here is known. That was 2 hours.
So by clearing the fractions, would you
Now, it's also important to think about what does X represent here? What does X actually... Is it the total time?
It's the time that.
What else could it be? Could be the total time. It's not the total time though, actually. It's something else. Think about it. X is the same for Elizabeth and Gary.
Because the time isn't
X
unknown.
divided by 2. How that long?
So Elizabeth has been working for 2 hours. X is the amount of time that Gary and Elizabeth work together. Right? Does that make sense? Because that's why it's the same for both of them. Now if we wanted the total time, like if this had said, how long will it take in total? Or how long in total did it take for the locker to be cleaned? Then we would want to set this up a little bit different. Okay. But X here is just the time that they're working together. So how long will it take? In other words, how long will it take after Gary shows up 2 hours late?
48.
That's X. And then we're going to solve for this. So what's our lowest common denominator between 8 and 12? It's not going to be 48. 24, right? 24.
2.
So multiply through by 24. 24 times 2 over 8.
So
The 8's going to cancel. I'm going to have a 3 times 2.
6.
6. 24 times x over 8. 3x. 24 times x over 12.
2x.
2x. 24 times 1. 24.
I thought it was.
Did you subtract the 6 and then combine the...
Yeah, so let's subtract our 6. And at the same time, I'm going to combine these two into one term. So 5x equals 18. If I did that right. X equals 18 fifths, which is 3 and 3 fifths. 3.6 hours. Right. So it will take them...
Do we have to write it out like that on the answer, or can we just write 3.6 hours?
Write it as a sentence because it was asked as a sentence. That's a good general rule. We'll take them 3.6 hours working together. Questions about that type? So remember, these could be trickier if it said that the wording of these is a little tough, actually, just in general. It's always going to be a little hard. Do they mean how long will it take in total, or do they mean how long after Gary shows up? And I think generally with the ones from this book, they're asking after that second person shows up. Okay? But if it says in total, then they're asking for that total amount of time.
Should have been 18 hours and 112.
And 100.
Oh, and then the hour.
Okay. Can I erase this one? We're going to do another slight variation. On the same theme. Okay. Does anyone here own fish?
I did, but
I
they all
do,
died.
but my brother
Karen's-
took a bowl and mashed it.
What?
What?
Fish.
Karen's fish tank
It was depressing.
I
Can
had
be
11 fish.
filled.
Infected with some fucking disease. I'm dead.
and
It's
6 hours.
Wow, that's pretty good.
That's like good.
6 hours.
Unless we're doing it with like
No.
It can be drained
in 1 hour.
in 15 hours.
What?
Why does it take?
Wait, how?
It takes a long time to drain
No, it's just the
her
tiny
tank.
hole at the bottom.
Now, the question is, if Karen
Just be.
forgets to close the drain,
Uh-oh.
Yucky.
How long till the fish all die?
That's horrible.
how long until the tank is full?
What?
Wait, if she forgets to close the drain?
Oh, it's
So
it's
what's
a
going on
drain.
here? Yeah, I hear a lot of whats.
Oh, like if she's filling it up and she forgets to close the bottom.
Right.
Okay.
So
That's weird.
she still has the hose in the tank, right? That's what's implied here. She's filling up the tank at this rate, but at the same time, what's happening? Water's leaking out the drain. Okay.
So wait, isn't it just 6 minus 15?
Yeah, so in this case, instead of adding the two things, we're going to subtract the two things. Okay? So, and what are my rows going to be here? Think about that for a second. And raise your hand when you have a guess. Don't call it out. So raise your hand if you can tell me what these two rows are going to be. Because there's only one person. So I can't put Karen for both of them. But I'm just going to wait a few seconds. Think about that. What would the two rows be? I'm going to see a few more hands. Amy, what would our two rows be?
Wouldn't it be the time that it takes to fill it and the time that it takes to drain it?
Good. So filling and draining. Alright. Now let's look at our boxes. Can someone else raise your hand? Tell me any one of these boxes. I don't care which one. But I do care if you raise your hand.
Oh, thanks.
Alex, go ahead.
The rate, there wouldn't be 1/6.
Good. The
And
rate
then
for filling would be
drain
1/6.
15.
Okay.
And time is
How
also
about-
X.
Yeah, time is F.
How about someone else? Raise your hand. What's going to be another box? Sal, go ahead.
Time will be X.
Time will be X in both cases. Now, do I have to think about when I set it up, adding or subtracting something else?
Well, you have to subtract the two of them instead of add.
You have to
Okay.
subtract this.
But in terms of time, are my times actually equal in my equation? Are they draining and filling for the same time?
Yes.
Yes. Right? I don't have anything that says like she opens the drain 2 hours after she starts filling the tank. There's nothing like that. So the time will be equal, right? The time will be equal for both. I don't have to worry about that.
Well, what
And then
what if it wasn't?
last column, work. I'm just going to multiply these two columns together. 1/6 times x is
X over 6.
x over 6. And 1/15 times x is,
15 over X.
it's not 15 over x, but it is x over 15. Okay, now I have to think about what's going on. So I know that my tank is filling at this rate. But it's draining at this rate.
Minus.
So what am I going to do?
Minus X.
Minus. I'm going to subtract x over 15.
Oh my god.
And in the end, I'm still filling up one tank. So I still have equals 1. What's my lowest common denominator between 6 and 15? 30.
30.
X over 6 times 30.
Is 10.
X over 15 times 30.
10.
2.
And
Negative
30
2.
times 1.
Oh no.
30 times 1.
10.
3x equals 30. X
Oh, it was 10.
equals
10.
Okay, so it will
What's
take
here?
10 hours
Okay.
to fill the tank.
It's
still writing down.
Yeah, I'll leave that one up there for a second. Any questions about that type of problem? So this time, instead of adding the two things together, we had to subtract one of them. Okay? We're going to do another example somewhat like this.
Neat. Is this the homework you're on today?
Is this what the homework is on
That's right,
today?
we're doing something different.
Oh, okay.
Yes.
Homework on basic.
Thank you for the clarification, Sal.
Nate, can we just start on the
Obviously, you were
No,
asking.
you definitely don't want to start on the homework
You're so
yet.
good at choosing
You
your
want the rest of these notes. You definitely want the rest of these notes. Can I erase this?
My notebook's almost full. I have like 2 more pages.
Do you want paper plate, Ed?
If your notebook is almost full, what should you probably do tonight?
Got a new notebook.
Get another one.
I'm taking this to high school. I'm gonna retake Algebra 1.
I still have my Algebra 1 notebook.
The cheat sheet.
I have it in my closet. I haven't looked at it in years, but I still have it.
Your
Okay.
book from when? From what age?
Well, I was in 9th grade when I took
How's
algebra.
your
Okay, let's look at another sort of problem. This is basically the same type of example, but it's not going to look like the same example at first. Okay, so I'll explain that in a second if you need me. We're going to go back to that first type that we looked at. So, let's see. Oh, I was going to do a cupcake one, but I already did the cupcakes.
I love cups.
You didn't cupcake.
Cupcake can be
On the homework, I put a cupcake problem.
Oh, no,
Okay.
just do a...
I've got a good one.
Cupcake in
Landon.
27.93 hours.
Landon can build a
Spaceship.
drone prototype in 4 hours. It takes Kareem 8 hours to dismantle it.
If Kareem was just...
If Landon
They're building and dismantling at the same time.
works while Kareem dismantles.
What? That's so pointless.
Hold on. You think stuff like this is pointless, but our government does it all the time. I mean,
I'm gonna go
wait,
with this.
this
This
is
is like follows in
how long will it
It's
take?
on video, Nate.
Watch out, the NSA is coming
Don't
for me.
post it.
They're gonna come for you.
They are watching you.
They have eyes and ears.
How long will it take for the drone to be built?
Aw. It's gonna be so sad.
Okay.
That doesn't make any sense though, because...
Yeah, why would you ever do that?
He just like follows behind him, just like screwing them and taking it apart.
Landon works while Kareem dismantles. How long will it take for the...
Alright, let's do the same thing. So, again, we're going to set up the exact same chart. Landon. Kareem.
How about Kareem just be 4 hours late?
Yeah. Okay, rate times time equals what?
Distance.
Work.
Work! Okay,
It will take 4 miles.
raise your hand. What is the rate for Landon? What is Landon's rate? Raise your hand, raise your hand. Landon's rate. I want to see some new hands.
What it would
Be great. So think about this. What he's doing over the time it takes. Micah.
1/4.
Good. And what is Kareem's rate? What is Kareem's rate?
What over 8?
Hands up. Serena.
What
Thank
over
you.
8?
1 over 8.
So...
Okay. Now, there is a different way of thinking about this. We could think in this chart right now, and if this helps you, then do it this way. We could think, oh wait, Kareem's rate isn't 1 over 8. What is it? Because he's not building one drone.
1 over 8.
He's taking a drone away. So we could think of this as a -1 over 8.
And then you would add them
And if
together.
that helps you, do it that way. If that doesn't help you,
Well,
then
you
don't
would
do it that
still-
way.
then you
Well,
would
can we
still
do
add
it that
them
way?
together.
let's do it that way as a class so that I can show you what that would look like. Now time, again,
X.
x. Work,
9.
we're going to multiply x over 4 and negative x over 8. So we have x over 4 minus x over 8.
Equals 5.
In other words, plus a negative x over 8. Right? This is the same thing as this. Equals 1. Because
What if it was
it's a messy
took him
one.
4 hours to build 900 drones?
What's my lowest common denominator between 4 and 8?
8.
8.
It took 3 hours.
8. 2x minus x equals 8. X equals
8.
8. It will take him 8 hours.
Or until he just like smash scream and tells him to stop.
It will take 8 hours.
Stop breaking my drone.
Right, or until they realize that they're doing opposite things and they communicate.
And they build together.
Communication is key, right? Kareem, why are you taking that apart? I just built that. Oh,
It's just cream should just be 4 hours late, and then we'd have
Right.
it solved.
yeah, if Kareem showed up 4 hours late.
The Leonard has a drone attack him and stop him from dismantling it.
Alright, I'm going to erase this one. We have one more type of problem to do. And we have 5 minutes, which is perfect. That's the exact amount of time that it will take one class working together to do one work problem.
Oh, on the last page of the notebook.
Alright,
Oh no.
this is what Sal asked, I think it was Sal, at the very beginning. Okay? This is, what if x is not the time? What if x is something else?
Wait, what if it's two different things? Like, what if it takes
And-
him 4 hours to build 3 drones and it takes Scream 8 hours to dismantle 6 drones?
Okay, so then what you would do is, it takes 3 drones can be built in, what did you say?
6 hours.
6 hours. That would be his win rate.
Oh, okay.
Okay? So you'd adjust the rate accordingly. I don't think you'll have any problems like that though. Okay. Alright. So in this case, what we're going to have the same setup, but I want you to notice as I write this problem, instead of saying how long it takes one person to do that job, in other words, instead of giving you their rate, I'm going to tell you how long it takes both of them together
Oh,
to do something. Okay? So I'm going to do this. Tess, write a story in 80 minutes.
Wow. An hour and 20 minutes, test go.
Working with Hindu. They can do the job in 30 minutes. How long would it take Hindu to write a story alone?
Shouldn't it just be 80 minus 30?
You would kind of think that when you look at this problem, right? Oh, 80 minus 30. And I can bet on a standardized test, like the ones that Gary gave you guys, 50 would probably be an answer, right? It's a
Just
really
to mess
good,
you up.
that'd be a really good, like A. Option A, 50 minutes. Oh yeah, 80 minus 30 is 50, of course. Right? Option B, 110 minutes. We're going to add them together for some reason. Okay? But in this case, because they work at different rates, it's not usually going to work out like that.
So the test would be 1/.
So, we have Tess, we have Indu,
Oh no, that wouldn't be
rate, time, work. Okay, we know Tess's rate. One story in 80 minutes. We know that Indu's numerator is going to be 1, but we don't know how long it takes her to write that one story. So we're just going to call her rate 1 over x. Now, it's important that you do it this way rather than just call her rate altogether x, because that's going to make the problem look a lot different. Okay? So let's say, instead of saying the whole rate is unknown, let's just keep that time unknown. Now remember, this column is how long they're working together.
So 30.
So it's 30 for both of them. Even though we don't actually know how long it takes, we don't know Indu's time. If you read this, how long would it take Indu? I would probably think, oh, time is x. But remember, it's this time, this down here, that's x. What we really don't know is how long Indu takes to do something, and that's her rate. So we put the x in the rate column. Time together, we do know that's 30 minutes. And then the amount of work done, just multiply through 30 over 80 and 30 over x. Our equation, we're just going to take this column and add these things together. I'm going to just simplify this right now. 3 over 8 plus 30 over x equals 1. Equals 1. Now, what is our lowest common denominator of 8? Yeah, 8x. Good. 8x. Multiply this through. 8x times 3/8 is 3x. 8x times 30 over x is 240. 8x times 1 is 8x. So the x actually canceled out of this term.
So just subtract the 3x,
Right? Yeah, let's subtract 3x from both sides.
240 equals 5x. And then you divide it by 5.
What's 240 divided by 5?
It's from.
Alright, how long does it take Indu?
13, 200,
X equals
100.
48. Good.
If you
48.
Well, minutes, not hours.
And this is minutes, right?
I can
So-
write a book in 48 hours.
So Indu can write a story. Indu takes 48 minutes to write a story.
Is that all of them, Nate?
That's going to be all of them.
And it's 11. Perfect.
So I did put one kind of bonus problem on the homework. Feel free to do that if you'd like to, but you do not have to.
Report cards are coming out on Friday, right?